welcome to 60 Minutes of Unscripted .NET Entertainment. As doctors of .NET, we prescribe healthy choices in .NET. I want to point out that my co-hosts are MDs in .NET. I'm a PhD. It's like the difference between a psychologist and a psychiatrist. I'm your host, Cam Soper, with co-host David Pine, and we'd like to welcome today's guest, Yair Halberstadt. Yair, please introduce yourself.
Okay, hi, I'm Yair. I'm a software developer. I've been developing software for about 4 years now. I currently actually work in my current job mostly in Scala, but I love C#, and so I contribute a lot to the C# open source ecosystem. Especially I like contributing to the C# compiler, that's Rosalyn, and I have various projects of my own, one of which is StrongInject, which is a compile-time dependency injection framework for C#. So that's what I'd love to talk about today. Yeah.
Awesome. Well, we're glad to have you on the show. And I know Dave was just telling me before the show that he was digging into the innards of Roslyn just this past weekend, I guess. So hopefully he'll have a lot of commentary as we go along. On that note, Dave, are you ready to do a checkup?
Let's do it. Yes, so I was very excited for today's show. Yair is going to be showing us some amazing additions to what I believe is already a strong foundation. So dependency injection in .NET it's a first-class citizen, which basically allows for the inversion of control, helps to provide unit testing capabilities, where you can have constructor injection, where you take on dependencies through the constructor of your objects, and typically you'll have interfaces where you're requiring these contracts, things that you're looking for, and you can consume them that way, and you can mock those things out. And dependency injection's been around. It's a design pattern that's been available for a long time now, but with .NET specifically, it's like I mentioned, a first-class citizen, so it's part of the framework, and that was new to .NET Core, whereas before you would rely a lot on external things. So if we take a look at this doc here, and you played the doc banner at the bottom, correct? I believe
I did, yeah.
Okay.
I took it off because I only play it like 2 or 3 times because it gets distracting.
It does. Okay, good. So in this doc, we go through a bunch of different ways on how to register, services, and how to kind of have that mindset. You'll basically start with a service collection, and then you'll end up creating from that service collection a service provider, and that service provider, like I mentioned, is part of the framework. Now you can do things on your own if you'd like. We kind of advise against that, but there's various ways that you could implement interfaces and require those concrete objects to be registered as services. And this exemplifies that. But rather than looking at the doc, I've actually put together, I have the source code locally, and we've upgraded it recently to .NET 5. So with .NET 5, we get top level statements. And so we've got a program class. We've got all these using statements. So these are all the things that we're pulling in. And then we are going to create a iHost from our builder pattern. So we're going to configure services. And when you configure services, this is where you get to register the various things that your application cares about in terms of dependency injection. So with this case, we're adding a hosted service, which is our worker, which is a background service that sits here in our process. And then I'm adding a scoped iMessage writer. And iMessage writer is wrapped to or corresponds, this interface corresponds to this concrete implementation. And what Yair is going to, I'm assuming with StrongInject, he's going to show you is that there's problems that can arise if you were to code things incorrectly, to where if you didn't have something registered, right? So if you accidentally don't have that, right? We remove that scoped line here where we're mapping our, let me put this line there. So if we don't have our scoped iMessage writer, but we were to build this out, and then we were to create our scope, and ask for that required service, at runtime, this writer would actually blow up on this line, trying to get that that writer, because we actually didn't add it to the service collection before. So this is basically walking up to the iService collection and adding things and declaring their scope. And the scope is important because depending on the use of the different services, you'll have things that might be singleton. So it's around the entire, there's only one instance for the entire life of the application. There's scoped, which can live, if you think about a web request, for example, it could live within the scope of that entire request response pipeline. And there's another scope that is evading my brain right now. But regardless, there is this problem that exists today with out-of-the-box framework dependency injection bits, and that is there's not any way for us to tell you kind of preemptively that there's a problem in this code. But with StrongInject, I believe that did you solve this problem, Yair? Is that correct?
Yeah, well, I hope so. That's the aim.
So I'm just trying to illustrate the problem, right? So if we were to run that, it would blow up on get required, because required is basically saying that it needs to be registered. If you were to do the other overload, or the other method, which is just get service, and you try to get that, this would just be null and it would continue on, right? So if we were to make sure that we do correctly register it, then and only then would it actually be registered for use, and the writer would be not null, and then it would work, and everything, the world's happy then. So that's pretty much the checkup doc, the example of .NET 5 top level statements, dependency injection 101, kind of basics on how scoping and the various parts work, and how you can request and require things within a scope and utilize them, and kind of hoping to illustrate the fact that there is this problem. You won't know about it until runtime, and Yair's open source project is here to save the day.
That almost sounds like a lead in to a hallway track, Dave.
It does.
Let's do it. So, Yair, the floor is yours. Tell us about StrongInject.
Okay, so StrongInject, as you might have got by now, is something that aims to do this dependency injection stuff, but get it all checked at compile time. And the way that we do that is using a new .NET 5 technology called source generators. If you want to know more about source generators, there was a great overview a few weeks ago by Jason Bock on this very show called, I think, Source Generators for Fun and Maybe Profit. So check that out if you want some background about source generators. But at a high level, source generators plug into the compiler, and they allow you to generate C# files on the fly. So you'll write your code, and the source generator can read all your code and generate some more code. And it's just ordinary C# it's generating. So that's something which you can use to do all sorts of fun things at compile time. Now, in this particular case, where I use that to create the code that you would usually create for dependency injection. In the past, there's actually always been a way of generating code, but that's generating code at runtime using system.reflection.emit, which instead of generating C# at compile time, you're generating IL code at runtime. And it's also additive. So just like you can only create new C# files with source generators, you could only create new IL classes and methods with runtime. But even though they sound superficially quite similar, there's a lot of subtle differences in how you would actually use them. And that's one of the things that I also want to focus on here, which is when you're working with C source generators, you have to rethink how you design your APIs. And by looking at StrongInject, maybe I'll go through some of the ways that makes a difference. So anyways, let's get down to some code. So maybe I'll show an example now. So here is a completely empty project. I think that's clearly visible, zoomed in enough.
Yeah. Mm-hmm. Yep,
right.
Looks good.
Okay, so it's completely empty. I haven't done anything, and I'll just show you what it takes to get started with StrongInject. So we'll start off by, of course, adding a NuGet package, and source generators are consumed just like any other NuGet package. You go into NuGet, you search for StrongInject.
While you're pulling that NuGet package up, we did have a friend here ask a question right away. They're saying, so basically you generate the DI code at compile time, and if there are errors, you're able to throw them at compile time instead of runtime. That's
exactly it. Yeah, that's exactly it. And let's show that. Okay, so we'll install StrongInject. Should be installed now. Let's use StrongInject. Great. And let's start off by creating the class that we want to inject. So let's say we have an app. It's quite a boring app. It's going to do this. It's going to print hello world, because what else would an app do?
This is what all apps do, at least when they start off, right?
That's it. They print hello world. So we've now got our app. Let's get rid of this. And we could, of course, do new my app dot run, and that would work absolutely fine. But that would be boring. We want to use dependency injection. So let's show how we do that with StrongInject. So the first thing to do is to define a container, which is what will create our app for us. So we inherit iContainer, which is a StrongInject provided type, and we want to create an instance of my app.
We do we do have a viewer real quick. Sorry to interject. They're asking if we can zoom in one more. It's a little bit hard for them to see.
Okay, is that better?
It looks good to me.
Mm-hmm.
Okay. Well, let me know if you want me to zoom in more. And
Will do.
So already I've got my first error. It's saying we're missing a partial modifier. And what's going on here is StrongInject is generating a partial class in the code behind, and you need to declare all instances of a class as partial. So partial classes are a way that you can split code for a single class among multiple source files. We just declare this as partial.
And that warning actually comes from the fact that source generators are generating a partial class on your behalf automatically, and that comes with just the compiler automatically. It's not something specific to your package, correct?
Yeah, that's exactly it. Now I might try using this container. So I'll say using var. In fact, let's use a C#8, I think, feature. Using var.
Thank you for that. I was hoping you would do that.
Oh, those using declarations. I love them so much.
You can actually, instead of doing var, you could do a container and then just new open and close parens too. So many different ways to do the same thing, right? I mean, come on.
Yeah, so we might want to use it like this. And now we run. We'll try building and see what happens. And we get an error. The error is we have no source, for instance, of type myapp. So we've tried to resolve myapp. We haven't actually registered myapp with the container. Now, ideally, you should be getting swigglies here. And the reason you're not is actually not a problem with StrongInject. It's that source generators are super new. The IDE integration is still being worked out. I think that maybe if I upgrade to the newest version of Visual Studio, this might be fixed, maybe not. Some of these features have sort of come and gone. I'm sure that, we're still, as I said, it's super new. It just came out in this last version. And if we wait a bit longer, we'll get all those nice things like squiggly lines under here with the error instead of having to wait till we actually build. But for now, we have to build to see that we've got this. So let's fix that. Register my app. Okay, so that's That's pretty simple. And now
So,
let's run this.
out of curiosity here, this is a little bit more declarative than I was assuming. So rather than walking up to the container itself and saying like register on the container, you actually provide an attribute that you can decorate your class with.
Yeah, that's true. And to be honest, I actually started off with an approach which looked much more like classical fluent DI methods.
Mm-hmm.
And eventually I decided that it's not really the best approach to doing things at
it's kind of
time.
yeah, I would agree with that. There's a bit of disparity, right? So you have this container that you're instantiating, you're defining it right there. It'd be nice if it's all in one basket rather than having to go look where you would be instantiating the container and registering things to it or whatever. I like that.
Yeah. So, I mean, maybe after I've shown a bit more, the basics of what you can do, I'll go a bit into that design decision and kind of my process of going through. So anyways, you've run and it prints hello world exactly as we want it to.
Woohoo! Clap! Woo! Yay!
Yeah. Okay. Let's go into this syntax a bit. This is an aside. This particular bit actually has nothing to do with this being a compile time. It's just one thing that I don't like about some existing containers is it's easy to forget to dispose your stuff or to have your stuff last a long time without being disposed. So by running everything inside a lambda in this run method on container, we can make sure that as soon as this completes, you automatically dispose all dependencies which were created for the purpose of creating that container. And
yep, interesting. So
and that way you avoid that.
I do have a question then about that. So what if does run mycontainer.run, does that return anything or is that void?
So you can have it return something. So if this was a string and we had it return hello world instead,
mm-hmm.
You could do and this should also work. Here we go, hello world.
So I think I'm getting confused on the names. So is iContainer an interface that is provided from StrongInject?
Yeah, this is provided by StrongInject.
And then run is a function that exists on iContainer.
Exactly.
Okay.
So it's different than the myapp method. That's I think there was a bit of ambiguity.
Let's name this as
F2. Yeah, if you were to you could refactor it and it would switch the other one. Yep.
Yeah. Okay. So maybe that's a bit clearer.
Yeah.
And
yep.
you can also use this normally.
Yep.
Again, using var scope equals. You could do that as well. Just use it as quite a standard container. There are two different options. Either way, let's get into a bit more detail.
Yep.
Let's say that my app depends on some other service. Okay. So we use that service, and then let's define an interface service. It's going to be an extremely boring interface, and let's have an implementation of it too.
That probably is the most boring interface I've ever seen.
I've seen some pretty boring ones. It's like a typical placeholder or stub interface.
So then we can register my service as an instance of my service. Okay. So let's try running this again. It should work. Yep, it did run, but we've stopped printing anything here. So.
Sorry, my questions led to non-operating code. Typical. Very, very common.
Yeah. Okay. Let's run this again. And here we go. We're back to printing hello world. So we're able to register my service, and it comes up as an instance of iService.
So then when you register that register attribute, the order of those types are important, right? You
Yeah,
can't have
so
the interface first and then the concrete implementation of that interface second.
Exactly. It's actually, this is the param, so you can register my services, lots of different services if you want. You know.
So then, so it's params. So the order doesn't matter.
So it does, but the very first one is different. We can look at the signature here if you want.
Yeah, yeah.
So you see it takes the type which you're registering, and then a bunch of params which you're registering it as.
Interesting. Okay. I might have more questions about that in a little bit. I'm thinking.
Okay, and you can also give it a scope, just like we saw earlier with ASPnet. You can give it a scope here. You can say it's single instance, or it might be instance per dependency, or instance per resolution. Instance per resolution is a little bit like scoped in ASPnet. I gave everything different names. Maybe that was a bad idea, but.
Well,
yeah.
It's very explicit then, right? Then it's I kind of like that actually, because everyone, one of the common complaints about transient and scoped is it's not as obvious as singleton. Singleton's very, very obvious. Transient is like, well, what does that actually mean versus scoped, right? So I think that's pretty clear. Your instance
Actually, as you say that, Dave, I'm sitting here and I would struggle. I would be able to use scoped and be able to use singleton. I'm struggling to place when I would want to use transient. So let's explain that real quick.
Okay, so transient is when you want a separate thing for every single instant that you, or in my case, it's instance per dependency.
Right. So
every single time I have one of these, I'll create a new instance. To the extent that if I have a parameter, if I have a method which takes the same thing twice, I'll even create two of them for that constructor. I think generally it's for things where you have state which is local to whatever you're using, and you don't want that state shared anywhere else. For example, imagine you had a calculator. Then and each thing had its own calculator. You wouldn't want that calculator shared between all different things, and your sums being added up to other sums. Yeah.
Yep.
So that's okay. So this is the really basic stuff. Now there's the obvious question, which is, how do I do dynamic stuff? If I'm doing this at runtime, I can do something like, if my config dot register a, then register a. But here we've got super declarative code. This all needs to be decided at compile time. So I can't do something like that. How can I make it that that I can? Let's take a really simple example. How do I allow us to choose between having two instances, implementations of a service, based on some condition, based on some config? So one of the ways you can do that is with factory methods. So let's create a factory here. Firstly, let's have two implementations of that service. So my service A and my service B. And then we'll register both of them. We'll register them this time as themselves. Different scopes for them, why not? And then I could say over here, service. We'll take an instance of my service A, an instance of my service B, and do something like if my config which we could pass in as a parameter to the container if we wanted to. And because I can't be bothered finding a config object, I'll just pass in a ball. Okay.
Thank you for using the tooling. I was going to say that when you started typing. I was like, do it. And you would use a ternary expression here, right? Yes.
Yeah, exactly.
I'm like in your head. That is so funny.
I've got my naming inconsistent here.
Yeah,
so this is a way that you can inject dynamism into your compile time code. Now, there's an obvious problem you might notice here, which is I'm going to create an instance of my service A and an instance of my service B, even though I'm only ever going to use one of them.
Mm-hmm.
Now, that might not be a good idea, but an easy way to get around that is injecting either a func or a lazy. I'm going to start off injecting lazy here, and I'm going to try compiling this. And you're going to see that, again, we're going to get an error. So we have no source, for instance, of type system.lazy myServiceB. And the reason why is because lazy isn't actually an inbuilt type in StrongInject. You've got to import it. However, you don't need to register it yourself. You can register a module which I've already created. And anybody can create a module. There's nothing special about this module. And this is... I think it's called lazy module. And plus over here, let's say service A, fonts. Okay. And that brings us, that brings lazy into scope. And this time, when I run it, it all compiles fine. And let's take a look maybe at lazy module. You can see it's, oh, that's a pity. It doesn't. Oh, here it is. So you can see all it is a generic factory I've defined, which takes a func and creates a lazy out of that.
That's awesome. I'm laughing at Jason Bach's comment here in the, chat. Oh God!
Okay.
With regions, he loves regions. That's his favorite thing. I think we're going to get him another mug that says "I heart regions."
Okay.
I was going to ask you, so could you actually slightly modify these services to be a little bit more fun to maybe print, service A, service B, so that you could exemplify that your toggle does in fact actually work the way you're defining it?
Okay, yeah, so let's create a field and let's console.writeLine service dot get type.
There you go.
And let's see what we get. And here it is. We're using my service B. And now let's change this around and
false.
Have this true. Okay.
That is so much better than Hello World. I'm going to applaud for that one. I hope our attendees are. That is great. That is cool. I love that.
Yeah. It's what we wanted this app to do. It's what it was born for. So I think that gives an idea of some of the basic stuff. And obviously, if you want more info of all the different stuff you can do, there's a huge README. I'm not the best at writing docs, but I've tried my hardest here. And,
I know that people will appreciate that. That's all people want from open source is, the authors to give it their best effort, and this is certainly that. I did have one question before you go to jump to that real quick. Can you go back to the code? I wanted to ask one question. So if you comment out line number 12.
Okay.
Are you expecting that this won't compile?
Yeah, I very much hope it won't. And here we say, error was resolving dependencies for my app. We have no source, for instance, of type myServiceB. Bravo,
bravo.
Yeah. And in case it interests anyone, you can actually debug source-generated code. So I might set a breakpoint over here. And now let's run this. Oh, wait, we need to uncomment this.
Getting lots of love here in the chat.
Okay, great. And yep, here we put it here, and let's see where we're getting this called from. And you'll see we've got this quiet generated looking code over here, which is the code that I've generated with lovely variable names like this. Actually, I have a pull request, which I'm working on at the moment, to give slightly better names than 01.
No. Underscore underscore one. Yeah.
But I'm hoping that you won't need to look into this too much. But it's great that if you do, you can just step through this code. It's normal code, you can step through it.
I want to look a little bit more at it here. So there's a global 01 or 02, 04. So one's a func, one's a lazy. And then those are the individual services. I'm assuming that's the return, the 01.
Yeah.
Okay.
Yeah.
Why is there two my service Bs? Because it's registered multiple times, right?
Let's take a look. Oh no, because one's a lazy. It's one's a lazy and one's a func. We create the func, and then we pass the func into the lazy, and then we use that to actually instantiate everything.
That's funky.
Pretty much.
Oh, Dave. Oh.
I had to do it.
Okay.
I had to do it.
I'm going to zoom out a bit more.
And I think we should start taking wagers on, because one of our guests is cheering for 01 to win.
Yeah. If you want to actually see, if you want to be able to see the generated code without having to start the debugger and set a breakpoint, they've recently added support for this. So if you go this, I don't really know how to zoom in here. I don't know if it's possible. So I hope you can see it. But you'll see that you have dependencies, and you've got a list of analyzers. Source generators are actually just a type of analyzer. You go analyzers, StrongInject. StrongInject will generate the source generator, and it'll show you the generated file over here. And that's your way of checking. It's exactly the same thing, but you don't need to debug anything to see it.
Can you zoom into the actual source code a little bit more, though?
Okay, sure.
Okay. Yeah, there was another ask here in the chat. So awesome.
Okay, great.
So is that pragma ignore warning? That's generated from your stuff as well?
I generate that as well. Yeah. So maybe now let's talk a little bit about why I chose to have attributes over here.
Yeah.
And in fact, I started off without using attributes. I started off having some system where you would write code very similar to like that you might write for AutoFac and or ASPnet or iService collections. But the problem is we obviously can't run this code. So you've got to read it at compile time and then generate code based on that. But we can't know at compile time which code will actually end up running. So if you start doing something like if A, then register this, else,
and that's very common. That's very common. That's super common. That's pseudocode. I mean, that's part of the templates, literally. I mean, for like ASPnet core and stuff. So yeah.
Exactly. If you start doing that, then we just basically either have to try solving the halting problem and predicting what code's actually going to run at runtime, or we have to bail out and give you a compile error. And the best thing about Fluent, and I love Fluent registration, but the best thing about it is it's literally just code. You can do whatever you want with it and work out how things are going to run. And you lose that biggest benefit. And instead you have to guess, okay, will the source generator accept the exact thing I'm about to write, or will it not accept it? And so in the end, it actually ends up being more, ends up giving a worse user experience. Whereas when we have attributes, we're limiting what you can do. And so you don't have the ability to do any of this stuff. And that makes it much easier because you know that whatever you can write will work.
Right.
So that's I felt after a bit of experimenting that provided the best user experience.
I really agree. I tend to agree here. I think this is a lot more declarative and decorative, and it makes it very explicit. And it's certainly easier to try to infer usage, and I think it was the right decision.
Okay, great. I'm glad that I've got support in that. So maybe now let's take a look a little bit at some of the aims of StrongInject and see how the fact that this is a source generator impacts some of those aims. So I've written down 5 aims here, which is some of the stuff that guided how I made these decisions. We've seen some of these points. The first thing is I want this to be compile time checked, and that's straightforward. We've seen that already. If you don't hook things up right, you get an error, and that's really, really useful. Secondly, there's performance, which is because we're able to generate this all at compile time, we can avoid anything like dictionary lookups. We can avoid any reflection, just really fast code. Now, I have to admit that this isn't quite as true as it once was. So I write over here, this should be the fastest code it's possible to generate. And the first implementation was the fastest code that it was possible to generate. Since then, I've made some sacrifices to performance in order to get extra safety, because there's things which, involving what happens if you have an exception whilst you're resolving your types, and you need to make sure that things are disposed. And that causes a tiny bit of a performance hit, but is really painful boilerplate to write, and is easy to cause you problems if you don't write it. So I felt that safety, which is the next point, encourage best practices, and it's about making sure that we use this stuff safely. And in terms of encourage best practices, that's part of what I showed earlier, where I like to have this lambda inside the run method so that you make sure that you you don't forget to dispose the types that you generated.
Do you have any type of concern with, like, lifting or elevating variables out of the scope of the lambda? Like,
so definitely it's easy to break this if you want to break this,
right?
But with the assumption that we're encouraging best practices here, we can't force best practices. We're giving you the rails so that if you just do, and we're used to lambdas being expected to be side effect free from link. We know that when you're doing a select, never try and do side effects. So exactly the same principle here. Don't lift things out of here into local variables.
We did have another question real quick here. Andreas is asking, can you also register a delegate instead of a factory? I noticed that there was a factory attribute, so I'm assuming that the attribute is solely what matters there, right?
I'm trying to understand what exactly you mean by registering a delegate. If you mean instead of actually creating a method, where is it? So you mean doing something like register, and then this code won't work. You mean doing something like that?
Yeah, go ahead.
That feels like what the question was asking, but I'm not sure.
Yeah. So unfortunately not, and that's because attributes are quite limited in what they can support. They don't allow you to put a lambda in. And I had to think of quite hard until eventually I came to this solution where you write a method in the thing and you put factory to it. It is slightly more verbose, and that is a pity. Maybe future C# versions will give us a better way of doing this. On the other hand, it's actually got some advantages. Like, for example, a lambda can't be generic, but it's super easy to register generic generic stuff with StrongInject. I won't bother doing everything else here to get this to work.
Right.
The point is you can have a generic factory method as well as a normal factory method. Let's go back to some of the aims. Yeah. Okay. And there's no reflection or runtime code generation over here. So one of the advantages about this is performance, obviously, but also there's certain platforms where runtime code generation just isn't available when you're running on UWP or iOS. And it also is very useful when you're linking stuff. If you want to reduce the size of your apps, you can link out all the stuff that you don't, trim out all the stuff you don't need. If you're doing runtime code generation, you can't know at compile time. The linker can't tell what things you're using. And so there's all sorts of config files you can use to say, oh, even though you can't tell this from my code, but actually I use this. But if you use StrongInject, everything's all linked up at compile time, and so you don't have to worry about this. And finally, StrongInject supports async resolution. And as far as I know, I don't know of any other C# source generator which does support async resolution. And it was kind of a pet peeve of mine because, you know, it's really common in, whilst you're, as part of your startup codes, in your, you know, as part of your, what's it called? Getting all your classes ready, to have to read some file or do some I/O to get some configuration or initialize some cache or something like that. And you have to resort to all sorts of hacks when you have to do that if you're using a IOC container which doesn't support async. And there's all sorts of you know, great reasons why you might not want to support async in containers. But ultimately, I felt like all those reasons didn't quite add up to the fact that I always wanted to do this, and the hacks that I had to do to get around it were even worse than the cost of just allowing the generator support async. But there's a good reason why your average IOC container won't support async, and that's firstly, async code is actually super hard, is super complicated to create in I/O. If you take a look at what the compiler generates for you, if you write
don't do it. No, don't do it. Don't do it. Oh, no. Don't show him the state machine.
So this is SharpLab. If any of you haven't checked it out, I wonder if I can zoom this in. Okay,
yes, you
great.
can. Yeah.
So then,
we've shown this on the show before several times. It's always great to show.
Okay, so it shows you what the compiler generates. So let's have the simplest possible async method that you can do. Okay. This is the simplest possible method, and this is what the compiler generates. You can't even see it in one screen here.
Well, I would argue that that's not the simplest. If you remove the async and await keywords on the left, it's more simple technically.
Okay, even then, you get a pretty big state machine.
Do it.
So you've got this. Remove the what?
Yeah. So go back on the left. Zoom in some.
Okay. Sorry.
Yep. And then if you just do, put back what you had there. Yeah. And then delete async and await keyword.
Well, that's not an async method.
And then return it. Right. Well, I mean, it's a task returning method, but
okay.
you don't end up with the state machine is the point. The async and the await keyword. Yeah,
let's say we did something afterwards, so we couldn't use that trick.
Right. But yes, your point is valid. I'm just trying to be a snob here.
Okay.
Dave, stop. Dave, stop abusing the guests, please.
No, I'm not. All right, keep going.
All right. Yeah, so you get this huge state machine, and the compiler's already done all the work to see how to generate this. But if you're generating code at runtime, you don't have access to the compiler. You're generating raw IL, and you really don't want to re-implement the entirety of async await in your IOC container. So you've kind of got an incentive to say, no, we're just not going there. We don't want to do that. Or to use less efficient methods like task.continue with, and things like that. So the first thing is the complexity is way harder at runtime than at compile time, when I just generate async await code, same as anybody else. And the second reason why you might not want to do this is that, where is it? Okay, here we are. Then if you register some types which require async resolution, and you register other types which require sync resolution, you never know whether or not you need to resolve stuff synchronously or asynchronously. So you'll start doing something like myContainer.resolve, and then it will blow up and say, sorry, this needs to be resolved asynchronously. Or you just always do resolve async, and then you're doing that even when you don't need it to be asynchronous.
So then you end up with overhead of the generated state machine code and stuff like that, yeah.
But also just complexity in your app. If you're doing a simple app, you don't want to have to think about async await. Whereas because we can look at compile time and we can see at compile time whether or not something requires async, we're able to make sure that we actually have two interfaces here, iContainer and iAsync container. And if you're doing iContainer and you try to resolve anything that requires asynchronous resolution, you'll get an error. So one way that you might have, let's say that this had to be resolved asynchronously.
Mm-hmm.
And we tried to, let's make this async. Okay. We tried building this. We should get an error. Here, iService can only be resolved asynchronously. So the solution to that is to make this an iAsync container. And at this point, you'll see that firstly, we need to make this await using so that we can expose async everything. We have to resolve async, and it's await using. Okay. In fact, it's easiest to do this with the run thing. And you can even, if you have to do await inside this thing, okay, great. What's this? Okay, oh wait, we don't have any scope anymore. Okay, await myContainer.run async. And we can, that will resolve it asynchronously, run this method. If need be, this could even be an async method, which would run, and then dispose everything asynchronously afterwards.
And then does it take an async lambda expression in there then?
Yeah, so I can have this return task. And you'll see that this will work fine. Or I could even just make this an async lambda directly.
Yep.
Okay. So there's two ways in which you can register something as requiring async resolutions. The first is if you have a factory method which returns a task or a value task, then we know that that requires async resolution. The other way is you can mark something as requiring async resolution by implementing I requires async initialization. And this is a bit of a hack because C# doesn't have async constructors. You can't say in the constructor that this has to be made asynchronously. So instead, we use a method where you create it, you construct it without any construct it synchronously, then you initialize it asynchronously after you create it. I'm not amazingly happy with this solution, actually. And the reason why is this forces you to depend on a StrongInject provided type. And I don't really like doing that, because ideally what you want is for your code to have no dependencies on the dependency in the IOC framework. And you just have, on the outside, you have a model which takes care of the module, which takes care of all the registration code, and that's the only place where you'll ever reference StrongInject. Whereas once you need your services to implement requires async initialization, then that kind of ties StrongInject quite deeply into your code. There are other patterns you can use. As I pointed out, you've got this, you can use the factory method to initialize something asynchronously, which allows you to move that code outside of the class and into StrongInject itself. And there's also a more funky solution where you can provide your own interface and then register a decorator which handles it. But I think that might be more involved than we want to get into right now.
So I'm imagining all of the entity framework source code out there that requires like the initialization of a database and seeding it with data and whatnot. And so out of curiosity, if those services were, implementing the I requires async initialization, and you could call that async function, what if those services then required external services then from your container? Would you be able to inject those then? And how does that, the resolution of all those?
So anything it requires can be done in the constructor as normal. You still have a constructor.
And I'm assuming you can chain asynchronous initialization services then.
Yeah, exactly. I can pass in my service B in here, or whatever I want, and that will just work. Okay, so one of the cool things about this this async resolution is actually it can parallelize your stuff for you. So if you have loads of different stuff which calls, which all does a database query, StrongInject works out what order it can run them in, so that we can kick off everything, what is the best way to run them, that we can kick off everything that calls the database in one go, that all call the database in parallel. And then we wait for the slowest task rather than having to wait for each task one after another. And that way, everything's ready much quicker than if you, you had to wait between each one.
That's absolutely beautiful. My hat goes off to you. That's awesome. Very, very well done. Very well thought out and architected and designed and implemented. And I'm eager. So one thing you were starting to show, and I don't know if we got off track a bit, you had an actual ASPnet core app up. I was curious how this would tie in with that. Like, how do you actually start using it within some of the existing?
Okay, great.
That was my
question. This is
I'm wondering if we could, we're winding down on our show now. I'm wondering if we could go through the boilerplate, like what I would do for an ASP.NET application.
Okay, so ASP.NET raises an interesting challenge. By the way, if you want to find this code, this is all in the samples folder in StrongInject. So you go to StrongInject, look at samples, you'll see it in ASP.NET sample there. But it raises an interesting problem because it's got its own way of doing dependency resolution. And it's set up everything, everything's already pre-registered with their modules in a specific way. But its whole technique assumes runtime code generation rather than compile time code generation. So our choices are either to basically say, scrap everything that ASP.NET have done, re-register all the ASP.NET components with StrongInject and just use that, or to find some way to integrate the two. And the problem with the first one is that's a huge amount of work, and it means that every time, you can't use any of the existing documentation, you can't use anything that exists, and every time there's an update to ASP.NET, you've got to re-register everything. It just doesn't make sense to fight the framework. You want to work with the framework. So we have to integrate between the two. We can't use StrongInject to resolve everything all the ASP.NET components, because that's already set up in its way, which just won't work with StrongInject. Instead, we find a way to have two-way integration between the two. So what I did is I've had you can create a container for any particular components of ASP.NET Core that you want to resolve using StrongInject. So for example, controllers are a great idea because they tend to be quite self-contained, and you can at least make sure that your controllers, you can validate at compile time that your controllers will be resolved correctly. And you can create a container for that controller. Where's the container? Here.
Now that add transient using container or whatever that method was, that's, I'm presuming that's an extension method?
That's an extension method. So I create a container for weather forecast controller and user controller, which are my two controllers. And then I can add in a very similar sort of thing way as you would add services to the service collection in ASP.NET. You can use my extension method, which I've provided, which can then tell ASP.NET that when it wants to resolve the weather forecast controller, don't do it yourself, go through container. Using, that's the container we've seen earlier. And this integration works two ways. So on the one hand, we have integration that ASP.NET can call into StrongInject, but at the same time, StrongInject can get stuff from ASP.NET. And the way it does that is by taking in a parameter. It can take in basically any parameter that's already registered with ASP.NET. So in this case, I can say iService provider, but I could also make it something specific. I don't know which types ASP.NET takes specifically. And then we can call that service provider to get a logger, because obviously you'll register loggers with ASP.NET in the normal way, but you can still use those loggers inside the StrongInject container.
Interesting.
So is that all the wiring up that has to be done? Is everything else transparent from that point on?
So there's three lines that you need to do. So the first thing is you need to tell ASP.NET to resolve controllers to service providers. This is specifically if you're using controllers, because ASP.NET doesn't actually use normal dependency injection for controllers. Controllers are special and are created some other way. I don't know why it's done that way, but that's how it is. So you need to tell it, treat controllers as normal types and resolve them using normal dependency injection. And after that, you just need to add all these controllers using these methods. That's pretty much it. These are the three lines you need.
And then as far as like the like the Razor pages or whatever, it's injected the exact same way as it would like the ASP.NET dependency injection framework.
Yeah, from then on, it's all the same.
So then if you go to like the weather forecast controller and you remove or if you do something to like kind of
okay.
Yeah.
So if I were to add a new type here, let's take this string S. We've got a new parameter. Let's try building this.
You would get a compile error at that point because it would say that it doesn't resolve. It's not registered, right?
Yeah.
Perfect.
Yeah, here we go. Error whilst resolving dependencies for this. We have no source for instance of type string.
Right. And without your library, that wouldn't have happened. Beautiful.
Exactly.
Very well done. Well, we're approaching the top of the hour, so usually we'll ask you for any closing thoughts here if you want to share any other additional resources or links. And I know I could continue on with this demo forever, but
okay. All I'll do is point you again to the StrongInject repository on GitHub. Take a look at it there. There's a README. Feedback is always appreciated. There's lots more features that could be added to StrongInject, but the only way to know which of those we should add is to get feedback. So tell us what you're using, tell me what you need, and we'll see if we can make it happen.
And I'm assuming since it's open source, you're open to external contributions from people who are interested in helping out or collaborating or,
Exactly. Contributions are always welcome. And if you do need any help, there's all sorts of ways that you can contact me. For example, Gitter is a great way to talk to me on StrongInject here.
Well, awesome. I can personally say that this has been one of my favorite episodes, much better than Jason's. No, I'm joking. Just giving him a hard time. This has been great. Thank you so much. I know it's late for you, so our attendees appreciate it. Thank you again.
Yeah, thank you, Yair. Who do we have next week, Dave?
I have to look. I'm not actually sure.
Actually, that was a loaded. That was
loaded.
A setup. It was a setup. I already know the answer. The next week we have Vahid, who is going to be discussing the Middle East's largest .NET-based maritime ERP system that his team built.
Awesome.
So be sure to tune in next week for that. And with that, happy Monday, and thank you to all of our viewers, and see you next week.
Bye, friends.
Bye.